Momentum is the measurement of mass in motion. Basically, how much mass is in how much motion. Momentum is a vector quantity and is measured in kilograms times meters per second. It can be calculated using the formula P equals mv, where P is equal to momentum, m is equal to mass in kilograms, and v is equal to velocity in meters per second. Large moving objects like cars and trucks have a lot of momentum due to their large masses, while something small, like a bullet, has a lot of momentum due to its extremely fast velocity. So let's have an example problem of momentum in real life. Say we have two cars driving on a highway. Car A has a mass of 1,300 kilograms, and car B has a mass of 1,100 kilograms. Car A is moving at an average velocity of 25 meters per second, while car B is moving at an average velocity of 30 meters per second. So which car has more momentum? Well, using the formula P equals mv, substituting all the variables that we were given, we see that car B has more momentum than car A. Now let's discuss the conservation of momentum. The conservation of momentum is much like Newton's third law, where every action has an equal and opposite reaction. In the conservation of momentum, the momentum of each object prior to a collision is equal to the total momentum of the objects after the collision. I think this example will help visualize that concept. So here's a clip of Newton's cradle. This device illustrates how much momentum is conserved by having the same number of balls swing each time they collide with each other. Much like Newton's third law, having one ball hit leads to one ball being swung back, and two balls lead to two balls being swung back. To further show how momentum is used, I have a mini pool table. In order to hit a ball into a pocket, I have to use the momentum of the cue ball to move them into the pockets. A pool table illustrates another related concept of momentum, collisions. The pool balls hitting each other is what's called an elastic collision, where the momentum and energy of the cue ball is transferred equally among both the cue ball and the balls it hits. So we have elastic collisions and then we have inelastic collisions. Inelastic collisions occur when two objects and their momentums and energy stick together and become one final velocity. Inelastic collisions can be seen in things such as dropping a medicine ball, because the energy is converted into the mat, which leads to the medicine ball not being bounced back. Inelastic collisions can also be seen in sports like football, where two players collide and they fall down to the ground together instead of bouncing off one another. So in conclusion, momentum can be seen in many things, from playing pool to bouncing a ball to driving a car. Calculating the momentum of certain objects can help scientists and manufacturers create safety precautions for products and overall make things more efficient. Using formulas like P equals mv, knowing the difference between elastic and inelastic collisions, and knowing Newton's third law can help you solve problems in physics.